morning. I dropped my water bottle there. Hello, welcome back. So this is part 2 of the Chapter 7 Study Guide review. Part 1 covered the first 6 questions on simplifying radicals. It also kind of did an overall review of the entire study guide. So if you haven't watched part 1, go back and watch that one because this is part 2. We were starting on number 7 on your study guide. So let's give it a read. It says, graph the given functions on the same coordinate plane and answer the questions below. Okay, so we're going to graph both of these things here and kind of recognize some facts maybe. Maybe where do they intersect? Which one's growing faster? Oh, which one's linear? Which one's exponential? So any of those. And it is okay to use a calculator. That's cool. Okay, so I'm going to show you the way I would do it if I were a student. First of all, I would look for the linear equation. This one's linear. The reason I know that this one is linear, it's because it looks of the form y equals mx plus b. This one, because it has an x that's flying high, aka in the exponent position, I know this is an exponential equation. So this one is exponential because I see that the x is an exponent, and I see that this one is linear. That means when I graph this one, it will form a line. When I graph this one, it will form a curve. Cool. So first thing I like to do is I'm going to tackle the line first because I think that's the easier one of the two. Always do the line first. I'm telling you right now, it's a good secret. So first thing we do is in place of x, we're going to substitute in a -2. Boop. So -2 plus 1. You can put that right into your calculator if you'd like, or just do the math. You can use a number line if need be. Now, -1. Boop. What is -1 plus 1? Ooh, that's 0. Let's plug in 0. 0 plus 1 is 1. 1 plus 1 is 2. You might start seeing a pattern because linear is a pattern that is arithmetic. That means you add or subtract to get to the next number. In this case, I can see that we're adding by 1 each time. And the reason we're adding by 1 is our slope is an invisible 1. Slope is a rate of change. Perfect. Okay, now we're going to go over to the graph and graph the line first. Again, please do the line first. So we have this beautiful little chart here. Here's my first point I'm going to find. So we're going to go over here, start at the origin, we're going to go back 2, and down 1. First point, done. Perfect. Hopefully you can see that. Yeah, it looks pretty good. Next point. You're going to go back to -1, and you're not going to go up or down. Perfect. Next one, you're going to go to 0, which is where you were, and you're going to go up 1. Perfect. Now you're going to go over 1 and up 2. You can see that beautiful straight line forming, which is really awesome. 2, 3. Nice. 3, 4. Go over 3 and up 4. And by the way, why not continue it? I mean, it's not going to hurt you. You can tell where the line's going. It's up 1 and over 1. Do you have to expand it? Of course not. Should you? Well, it might allow you to see things a little bit clearer. For those of you like, hey, Miss Miller, I got to graph that right here. I already knew what that looked like. It starts at 1. Yep. And the slope is up 1 to the right 1. You are correct. Cool. Good graphing. Now, I'm going to do the other one in a different color. Let's go with black. So, now I'm going to do this one. You can use a calculator. You don't have to, do it with me. Let's start with the easy ones, like 0. Anything to the power of 0 is 1. We've covered that so much, and the poster is still up. Anything to the power of 1 is just that number. Anything to the power of 2, you were multiplying that by itself. So 2 times 2 is 4. 3. 2 times 2 times 2. Think about that. 2 times 2 is 4. 4 times 2 is 8. Cool. But now we have to do these negative ones, right? You can use the calculator. So there's -2. If you use the calculator, what you would do is type in 2, this symbol that raises up the next number to be in the exponent position. Now you have to do a negative, which is a subtraction symbol. So hit subtract, hit 2, and then hit equal sign. Cool. Or if you're like me, I would prefer just to use the rules of exponentiation. I know that that's going to I need to take the reciprocal. It's going to flip downstairs. And then I know that 2 squared is 4. So some of you from your calculator got 1/4. Some of you on your calculator got 0.25. They are the same thing. Now if you have -1, you can do it right in your calculator again. How do we do that in the calculator? You hit 2, special button that raises the next number into the exponent position. Hit the subtraction symbol, hit 1, and then equal sign. And you're going to get the same answer I do, just using the rules of exponentiation. I'm going to flip it downstairs, and, well, there it is. He can't be there. A negative exponent needs to move. So you could have 1/2, or you had 0.50. So this one's done, and it looks beautiful. Now let's go graph it. So I'm going to go with the easy ones, like 0, 1. Oh, that's interesting. We have an intersection point there. They both have the same y-intercept. 1, 2, over 1, up. Whoa, we have 2 points of intersection. That's weird. That's strange. 2, 4, over 2, up 4. Ooh, that one's above the other one. That's cool. Ooh, we got some growth. And we have 3, 8. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Cool. And then we have these ones, which are very interesting. So at -2, you're at a smidge. The word smidge is just a really small number that's under 1, okay? And then the next one, you're at a bigger smidge than before. And remember when we practice graphing these, this is an invisible boundary that can't be crossed by this black graph. This invisible boundary is called an asymptote, which is a word that you'll study in really Algebra 2 Trig, which just means an invisible line that cannot be crossed. It's like hot lava. When you were a kid and you played that game Hot Lava, don't cross it. So watch how I connect. But don't cross this line. So it should be a curve that skims the surface of this x-axis. Now, there's this next question. Tell me some facts that you see. Well, first of all, there's some interesting things. They both have the same y-intercept of 0, 1. That might be important. I don't know. They have 2 intersection points. And those 2 intersection points are, we can see them right here. Oh, right here. Boop, 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 boop. 0, 1 and 1, 2. 0, 1 and 1, 2. Nice. And we can see them here too because they're exactly the same. Cool. We could say that f of x, this function, is exponential. We could say g of x is linear. We could say something to the effect of, who's going to eventually grow faster? This blue line or this black curve? Who's eventually going to far superior grow the fastest? And eventually it's going to be this exponential. So if you said f of x will eventually beat g of x, cool. Anything like that. And what does it mean that these are intersection points, by the way? That means when we plug in 0, the input of 0 gives us the same output of 1. The input of 1 gives us the same output of 2. Okay? So we have lots of little facts there. I'm going to end this video here. So this was video number 2 for our Chapter 7 review. Have a great day. Bye.